Hi, welcome to my channel. So, this is a quick intro video to describe what the channel's all about. And what it's all about is my project. It's a quick agenda for today. First I'm going to cover who I am, what the channel is all about, give an example of some projects, and set some expectations for the future. Who am I? I'm a programmer, and I've been doing this professionally for 15 years and as a hobbyist for a lot longer than that. I've worked in a lot of different industries, but it's mostly been around simulations of one type or another. I've done medical simulations, I've done engineering simulations, done real-time 3D world simulations in the games industry, and most of the jobs I've had that haven't been simulations have been similar mathsy, algorithmy work. I've worked in GPU drivers, done compression algorithms, things like that. My main languages are C# and C++, and I dabble in F#, Python, TypeScript, and various others. So what's the channel all about? Well, first and foremost, it's a place for me to talk about my projects. I have many hobby projects, and most of those I'm going to talk about here are programming related, but not all of them. But these aren't going to be programming tutorials. This isn't a how-to, that's not the idea. So why am I doing this? Well, firstly, I think these are interesting things and I like talking about them, and this gives me an excuse to do that. I also always been a big fan of Feynman's ideas about how you learn something by learning it yourself and then trying to explain it to someone else to understand where your gaps are, and then going back and learning it better. Thirdly, it will give me some motivation and hopefully some structure, bit of a kick to get on with some projects. Sometimes not in the mood, it's been a long day at work, and hopefully this will give me a bit of a drive to get on with it. Sometimes I'm a bit stuck in the weeds and it's hard to kind of think why keep going, feel a bit stuck, and hopefully this will give me a bit of motivation there. And finally, the good old programmer technique of rubber ducking. And if you don't know what that is, if you're a professional programmer, at some point you've almost certainly got on the phone or gone over to someone's desk and said, I've got this problem, can you give me a hand with it? And you've gone through and explained the problem, and suddenly as you're explaining you understand exactly what's wrong, you know how to fix it, and you go, brilliant, thanks for all the help, even though the other person hasn't said a word. Now this works because explaining a problem out loud forces our brains to go over the bits that we think we know, and sometimes there are flawed assumptions in those bits. And that just helps us reevaluate those assumptions and we see a solution. And the reason this is called rubber ducking is one of the pioneers of the extreme programming movement used to have a rubber duck on his desk who he would explain problems to when he was stuck. So what are the main projects I'm going to be covering? A few simulators of different types of things, which, given the industries I've worked in, makes sense, right? A programming language, quite interested in that project at the minute. A few games, and a marble room computer, which I will make more sense when I explain the project in a bit more detail. So, portfolio simulator. This basically is simulating various investment strategies against historical data. This is very much an academic exercise. Do not, under any circumstances, use this to make investment decisions. You can get the code on my Github. It is not intended for that at all. It is intended to explain and explore theories and ideas of how financial markets work. The data it uses is not very well cleaned, and for reasons I will go into in more detail when we talk about it, it will make horrible, horrible real-world predictions. You would be better rolling a dice. This is most likely the first project I'll do a video on because I've been really chewing on it lately. It's my main project for the past week or two, and you can see a little screenshot there of an early attempt with a very large amount of variance in return and not much return. And there's a programming language, so you see a mock-up of the editor. That's not very far progressed. Blazor, it turns out, cannot deal with content editable diffs very well, so I am going to go back to writing the front end in WPF. So it's quite an unusual language. Basically it's a playground for lots of ideas I've had about how a programming language could work. It's not intended to be a production ready language, it's not intended to take off and go into widespread use, and it's not really intended to be the perfect production language. It's just a way to play with ideas. So what makes it unusual? Well, probably the biggest departure, or certainly the most fundamental one, is that it's fundamentally based on queues instead of stacks. Lots of reasons for this that I will talk about in detail when I do videos on it. So one of its core guiding principles is that the code should flow from top to bottom. Whatever you're doing, you should be able to start at the start and just go line by line down to the end and create this massively linear code flow. And one of the ways we do that is with a non-linear IDE layout, which is hard to explain without showing you. When I have it working, I will demonstrate it. It won't be functional, it won't be object-oriented, it won't be imperative, it will be something sort of in between. Again, hard to explain. And in a similar vein, neither managed or unmanaged memory. One of the things that's really, really nice about queues is that the history tends to stay there. You're not constantly overwriting them, so memory management is much, much simpler. Not trivial, certainly not if you want to go fast, but simpler. And finally, something I haven't bullet pointed is content addressable code, but that's more of an implementation detail than anything else. Also be actor based, highly parallel. Yeah, that's the language. Star simulation. So, depending on how well YouTube compresses this image, you may or may not see there is a large cluster of points in the image on the right. So those points are points in a simulation of the physics of star formation. Not very far on with this yet. Currently we have tree gravity more or less working. Got a fairly major bug in it, but I will fix that at some point. And I'm about to start in on the smooth particle hydrodynamics, which is fluid simulation for those of you who don't know. That's how we simulate pressure and temperature that keeps a star from collapsing. So no particular reason behind this, it's just a subject that's always interested me. I've always wondered how they worked, I wanted to find out, so I decided to build one. What's that one? Tectonic plate simulation. So this span out of a game project, one of the projects I'll talk about in the games section. So I wanted realistic continents on a 3D world, and that turns out to be surprisingly hard to achieve. Basically lots of the things you can do for any, well, not for, well, yes, for any tessellation, but also things like just simple translation and like simple testing, are you inside a convex shape or not, or even a concave hull. Turns out much harder on non-flat surfaces, and the game I'm working on needs a spherical game world, and it needs to be procedurally generated, and one of the approaches I looked at was doing an actual physics simulation of plate tectonics. That turns out to be too slow. Academic departments run these things for months on supercomputers. You're probably not going to have that kind of compute power when someone's starting up your game. But it did turn out to be a fascinating subject, so I just span it into a project of its own. The idea is to simulate the movement and fracturing of Earth's crust to form various continents, have them collide, form mountains, that kind of thing. Few interesting areas in this one. As you can probably see, we have a little testing framework we've had to build. So obviously the mesh here that you're looking at is not spherical. This is because I'm doing not really unit tests, bigger than unit tests, but they're testing units of maths and physics to build up the kind of complex layered behaviours that go into the tectonic processes on Earth, and kind of working out how to test those 3D processes. It was an interesting challenge. I'll talk more about that when I talk about this simulation. And the basic concept is to use springs and buoyancy simulation over a geodesic mesh. That's that project. So then various games. A storytelling based strategy game. So this planet that you're looking at, that is the planet I was just talking about, and this is the game that tectonic plate simulator span out from. Now obviously this isn't using that, this is just moving shapes and hulls around on a sphere, and this is about the state of this game at the minute. We have some mountain formation and that's about it, so we need to flesh in the world and then crack on with the actual gameplay, which, like I say, is all about storytelling and building empires through myth and legend, and trying to have your empire outcompete the AI empires that are also building their own myths and legends. Then there's going to be a classic RPG dungeon crawl, so that does have a little twist to it, but I'm not going to talk about what that is here. I would like the player to discover that themselves. I might talk about the game itself, I might show some implementation, I just won't show that particular interesting bit. And then finally a logistics-based strategy game, so this is sort of a grand strategy, planet scale, scaled down planet, not a real planet, 2D map, well, flat map, effectively. And the interesting part of this game is that it's all about building logistics chains and supplying and training your armies rather than actually doing the fighting. And finally, the project I said was a marble run computer, so this is what it sounds like. Basically, you can make physical switches that use marbles as their inputs and use that to simulate, use those as logic gates and use that to build a computer. So obviously this is a physical project, but it will have lots of software elements. So the first is simulation, and that's what you can see on the right. That was a very early attempt at this project. Way too big a switch to ever be practically useful, but it was a very early attempt. Yes, so you don't want to build a massive complicated physical machine and find it doesn't work, so we will need to simulate it, probably in a game engine, I would guess, because you have most of the physics there. Layout, so lots of these, you will need lots and lots of switches. Even simple computers have tens of thousands of gates. You're not going to build that by hand, so you will need a layout tool for it. We will have to write one because, oddly enough, no one has built professional quality layout tools for physical marble-based chips. Who knew? And we will then need to turn that into a CNC routing instruction set somehow, because, again, thousands and thousands of switches, you're not going to be building these by hand. It is going to have to be a CNC process, which means first step, design switches that can be CNC'd in bulk, i.e. not CNC'd out of a piece of wood and then hand assembled. They need to pretty much be CNC'd and dropped straight into place. Have some ideas on that, but not fully worked it out yet. That's probably the least worked on project. It's one of those back of the brain projects that I come and have a crack at every now and then, so it might be a while before we have a video about that on the channel. So expectations for the channel. Don't have many would be the takeaway here. So when will I update it? I will update it when I have something that I think is interesting to show. There will be no fixed release schedule, and expect a vast amount of variation. There might be multiple videos one week, none for a couple of months. As I said, I'm doing this mostly for my own interest. I'm not trying to build a giant following, so I'm not going to be doing the things that need that. In terms of quality, also wouldn't expect too much. So I'm recording this on a laptop in my living room. As you can hear, I do not have a professional microphone, and building things is the priority over making very slick presentations. I'm not going to be doing much editing. As you'll have heard, there's lots of ums and ahs. I'm not clipping them out, not doing retakes. It's very much get the things on the screen, talk through it, and upload it. Because, like I say, the priority is to actually build the things, and that's why I'm doing all of this. And in terms of content, do not expect a how-to or a tutorial on any of this. I'm not going to explain how everything works in detail. What I'm going to do is talk about things that I think are interesting and that I think other people maybe haven't talked about, or that just I'm excited about. Which means there will be vast gaps in how things work, and if you want to follow exactly how some things work, you'll just have to figure them out. Some of this code is available as open source projects on my GitHub, quite a bit of it is MIT licensed. Some of the game stuff particularly, is not. Some of the marble stuff is not, because it doesn't really exist yet in any form, so feel free to take what you want from there. Don't expect support, as it were. But with those caveats, if you think anything I'm doing is interesting, would love for you to follow the channel. watch some videos. And that's it. So, just thank you for your time. Hope that you're going to find some interest in some of this stuff.